Welcome. Previously, we have recorded three videos related to data feeds, chaining VRF, and automation. And in today's video, I combined automation, time-based automation with NFT mints. So basically, we are going to build an NFT smart contract in which we will automate the mint function and we will mint an NFT every 5 minutes. As you can see, in the smart contract, we have mint 4 NFTs, and we also displayed the minted times in terms of the seconds, which starts from 1970, year of 970, and it counts until this time in terms of seconds. That's why it shows like this number. Okay, so let's get started with the code. Let me talk about the smart contracts that I imported first. We imported ownable smart contract to make sure implement the ownable mechanisms on the smart contract, such as extracting the owner, defining the owner of the smart contract, etc. We imported ERC 721 URI storage to take advantage of some of the functionalities, such as safe mint and set token URI, which makes it possible to set the token URI of our NFT. We also take advantage of counters library so that we can increase and track the ID of our NFTs. We imported strings contract so that we can convert our UINs or integers to strings easily. And lastly, we imported base 64 that makes it possible to convert SVG to base 64 string so that we can create NFTs with SVGs. Okay, so on the beginning, we just import these two smart contracts. Then we initialize strings using strings for UINT 256 so that we can convert our UINT 256 to strings. We initialize the counter so that we can increase and track the token IDs. We have created a mapping called token ID to mint time. So whenever we mint an NFT, we just track the timestamp. We store the timestamp over here so that we can show it on our NFT. Okay, this one is not. Is it useful? This one is for the defining the owner of the minted NFTs. So when we automate this mint function with minting every 5 minutes, the owner of the NFTs will be this defined address. So we will define it as our address. So all of these NFTs have one owners at the moment, and the owner of the NFTs is the address that we will define on the constructor. And we define the change address defined for automated mint so that we can change the owner of these NFTs. We also have a generate image function, so that makes it possible to create these SVGs of the NFTs. We start with SVG, then we define the XMLNS of this SVG, and we added two attributes called NFT ID that returns the token ID that we track and increase, and we also return the minted time that we also store in our mapping, and we put two string to the end of these features these UINs. Otherwise, the SVG will be broken. And while returning it, while returning the bytes of SVG, make sure to convert it to the base 64 string so that we can publish our NFTs in SVG format. We also need to define the get token URI function so that we can check the metadata of the NFTs. So I added the ID, description, mint time, and image of the NFT NFTs on the metadata of the NFTs. And also make sure to return them as string of base 64. Otherwise, they are not going to work. And lastly, we have defined our mint function. So at the start, we just increase the ID. Then we grab the newest ID with this function. Then we store the block.timestamp on a mapping so that we can display it in our NFTs and in our NFT images and in our NFT metadatas. And lastly, we run the save mint function to mint the NFTs, and we set token URI as the NFT ID, and we also need to get token URI and paste it over here to set the token URI of the NFTs. Okay, let's deploy our smart contracts. Make sure to pick injected provider. Okay, we have deployed our smart contract. Also make sure to verify the smart contract that we deployed so that we can create a time-based automation on the Chainlink application. Contract address. Also make sure to put the constructor argument that you used to create the smart contract over here. Then verify. Yeah, verification requests submit successfully. Okay, let's check it. So Folia, Ether scan. Okay, as you can see, we deployed and verified our smart contract. So next, let's just add it to automation. Launch app. If you don't have any links, make sure to get in links from the Chainlink faucet. Click the register new upkeep. So you just need to copy paste the smart contract address. By the way, if you don't verify your smart contract, they will ask the ABI of the smart contract. So to make it easier, I recommend you to verify the smart contract that you deployed. Next. So we need to define the function that we want to automate. Next. And we are picking the time. So we pick the time as every 5 minutes. Next. Okay. And let's define an upkeep name. Mint NFTs every 5 minutes. Define the admin address, the address that the payments will be made. So we defined this address. Make sure to increase the gas limits so that your mint function do not fail. Also, make sure to put 5 links at least because the mint function will require like approximately 0.5 link in each mint. So let's just register. After we deploy our smart contract, we will go to OpenSea testnets and track to our smart contract and our NFTs. We are on the last step. When it is done, we will go to OpenSea. Let's check the upkeep. Actually, Viva upkeep has appeared. So all we need to do is um, on these time intervals, on these specified times, we will the mint functions will be run by chaining automation, by chaining nodes, and we will have NFTs on our smart contracts. Actually, on this on the address that we defined. Okay, let's go to OpenSea testnets. Let's grab the smart contract address again. So make sure to wait a little bit because sometimes OpenSea might be really slow. So I will skip the video a little bit and I will show you the situation of smart contract, the outcome. So the automation have minted 2 NFTs at the moment, and we track our deployed smart contract on the OpenSea testnets. And let me actually make sure that we are in this correct smart contract. Yes, we are in the correct smart contract. So the NFTs have NFT ID 1 and 2. We also displayed the minted times with message that, sorry, with block that timestamp built-in variable. And if you look at the Chainlink dashboard of automation for the corresponding automation, we see that 2 functions have been run by chaining nodes, and we paid approximately 0.54 link. Actually, we have deposited 0.5 links on this automation, and it's consuming links for every run. And once this minimum balance will be reached, and it will stop. So make sure to deposit enough links and take this minimum balance into consideration when you are depositing link. So thank you for listening to me and see you on the lecture 5. Bye bye.